Hey, hi, good afternoon, everybody. We're at the end, almost at the end. Give me a little bit of time on this topic. Again, I want to thank our sponsors, Pragmatic, the Texas McCombs, MSTC, 280 Group, and hopefully, if we're ever back in person soon, next year we'll be at the Norris Conference Center. So today I want to talk about specifications, which is kind of a dry topic, I will admit, but it's something that is critical in the early stages of your product strategy and starting to define the product. And when it comes to like specifications, which can relate a lot of times relates to hardware-oriented products, or maybe I'll call it non-software products. But there can be an element in software as well as services. And I want to kind of go through that and show you some examples of what I call design specifications and performance specifications, and their differences, and then how they can then, as the product gets developed, how they dictate the outcome for customers and the benefits to those customers. A little bit about me. I've been in product for about 20 years in the tech space. I've done all sorts of hardware, software, services. I've done product marketing as well as product management. I started out as a cost accountant, and I think that goes along with most everybody, that not many, but I know these days there are a few that start their career as cost accountants. I've got a product that won an Academy Award, a technical Academy Award, and pretty proud of that. I'm an Oklahoma State Cowboy, so I'm a different shade of orange for those of you who are in Austin. But anyway, that's beside the point. Here to talk about product. So what I want to talk about really is the difference of the specifications I call, you saw earlier, performance specifications. And what specs are, first of all, there's their documented requirements. And they can take the shape of many forms, but it helps shape, the design of a product, what kind of materials might need to be used, what kind of coating might need to be used, all sorts of types of things, how supply chain or delivery of software or supply chain delivery of product or services is dictated. And there's all these different types. And the two ones I like to talk about. Here's, by the way, if you're not from Texas, you wouldn't get this picture, but we're not talking about specs, the liquor store. Two types of specifications I'll talk about is design specs and performance specs. And design specs really are usually written to dictate how a product is to be. It will say it is defined of a certain type of shape or color or form or something very specific. And most of the time it's the result of it. It needs to be purpose built, or in an appliance, or certain software pieces I'll talk about later, versus a performance spec that is more along the lines that here's how I'd like the product, here's how I like the product to perform, or how the product benefits the customer. And it's very open-ended. And of course, then the differences are engineers, developers, whoever is involved, solution architects, those types of people that are creating the product have some small or large latitude of how the look and feel, or the shape, or the tolerances of certain things, or again, back to, is it how purpose custom built is it, versus is it just something that we don't care how it looks, it needs to function at this level, and probably preferably at a level that satisfies customers, meets their needs, they want to buy it. So those are the two different ones, and there's a lot of elements that go into that I want to go through. And I'm, by the way, I'm an open book. I know some of you who know me. If you want, I want to make this interactive. This is more than just me talking to you. I want to get some feedback from you all, because I always want to learn and find out from your experiences or what you're working on. If you encounter this, or when you do, what do you see? And so one example I like to talk about is these big screens we see all over the place in malls and airports and even outdoors. Those two big screen kiosks on the right as representation of a visual piece of data, but then on the right-hand side, screens on the left, a bunch of different computers, a laptop, a server rack, a gaming PC, that little black box on top is a really small appliance. Any of those can run those screens. Because the software that drives the user interfaces and the video, for the most part, is very simple and doesn't take up a lot of memory and a lot of bandwidth in terms of the computing power and to send that over. In fact, the network switches are more, and the GPU, that the graphic interfaces and graphic processors are more important than the compute processors. But nonetheless, you can run a lot of things. There's times where then you need to run a network of those screens around the country, around the world. Then you might need something bigger. You might need something more specific in terms of how that data and video gets sent across a network. And that can be dictated by how you write the specifications from a developer standpoint, but also as a product manager, how you want to strategize and what the outcome is of that product you want to benefit the customer. Another example I think of when a software is APIs. And I know APIs can take a lot of forms, but APIs also are very, at least when they start out, they're very purpose-built. They're like, all we want to do is get you from here to there. It's like a lot of places, the glue to put two different other platforms together. And one great example that a lot of people don't talk about, but they use every day is, when you think about this event or any other event, you go to some place like Eventbrite and you register, and then you get this link that says, do you want to add this to your calendar? And I don't know about you all, I always I need to put on my Google Calendar and my Outlook calendar. And so think about that. If you've got more than one calendar like me, I have a Google Calendar and an Outlook calendar, and those APIs are very specific to each one. And then, I think the other options are a Yahoo calendar, 4 or 5 options, but each of those is run by an API that's very specific. It is a design spec because someone had to say, I need this to do this thing only, and nothing else. So that's something that has to be dictated in a way one's quality requirements for that type of product on the software side. When it comes to hardware, let's take a dishwasher from LG, and like a lot of other products, appliances, there's a big spec sheet, and it's got all the specifications you need. And by the way, it has to fit in a lot of standardized spaces in homes. So it's a very specific design spec amount of tolerances and measurements, height, width, depth. That's again very design specific. It would not be like a performance spec that say, I just need this to wash dishes that I don't know, and I can't say if it meets a temperature. That's sort of a design spec, but it's like it needs to sanitize it, and everyone would know what that means. But if an engineer had carte blanche on how to shape it, they might make it smaller because everyone likes things smaller, but then it may not fit very well, or maybe the electrical engineering counterpart doesn't. So again, these days, things like a dishwasher has to be very with a lot of high tolerances. It's a design spec. When it comes to then another product, a ruggedized computer. So it's a computer, it's a PC, whatever. And so there's a lot of spec sheets behind it. There's a lot of, design spec kind of things. However, in a ruggedized computer, for example, it's going to be, think of a cell phone tower that's outside. Think of, for a lot of us in Texas, the windmills out in West Texas, the oil rigs out all over the place. But when I think I'll just say West Texas, hot, humid, maybe not as humid as where I'm in Houston, but very hot temperatures. So guess what? A spec has to go up to 70 degrees Celsius. And if you've ever done that conversion, it's hot in Fahrenheit. It's going to be like 160 to 180 degrees. Because when you think it's going to be in a small, again, let me describe to you, in an oil rig, these days with IoT and industrial IoT, there are ruggedized computers almost at every rig or in every cell phone tower. I know there's one in every cell phone tower. And those are put up to extreme temperatures, actually both hot and cold, because you can see the cold is minus 25 C. So that's a sort of a design spec, but it's a performance spec because the outcome is the customers who buy those products and use those products are putting them in very harsh environments. And so a product manager knows this and knows that, okay, this is a very different type of technical product that I need to make sure it will work and still provide the same outcome as if it was in a data center that was, cooled in a data center, 24 hours a day, 7 days a week, 365 days a year. So as a product manager, one needs to think about these kind of things and what type of use is a customer. And sometimes the customer doesn't care. A very commoditized product just needs something that works, and in the tech world, it's any kind of appliance. So those are kind of other examples. But so, and this is a very common imagery of, are you building something a product that has an outcome for customer benefit, and what is that outcome? What is that customer benefit? And that's sort of like if you work with anything, the differences of a platform versus a product. In one way, the platform has to be outcome driven. It has to be outcome focused on it, because it's going to be a lot of other products and features within each product that kind of go the other way. Because a lot of times when you're working with software, especially like I think if you're maybe in a release train environment and you've got all these different teams in a scaled agile environment providing features. Before all that had to happen, there was one team that had to come up with the entire platform. And then as that platform gets established, then it's a matter of one, keeping it fresh by either updating the code of the original code or adding new features. And when you add new features, you kind of already fit within a framework that's been set or set of parameters, because the platform says you've got to fit it in this some box, if you will, just figuratively speaking. So depending on, and this is what I'm trying to get across this here is, as a product manager, when you're strategizing a product or a platform, you probably have the ability to be very outcome focused, and then therefore the requirements you send to your engineers, your dev folks, your solution architects can be very performance. I want this product to do this or these things. How it's look, feel, and other things can be, you got UX and UI designers that come in and
Andy,
kind of shape that.
I have kind of a question that came in, and I'm interrupting because it's on kind of point. Just clarify, for like an Intel Pentium chip, is that both a design and a performance spec, or do we have a way of thinking about that in one way or the other? Like when we're thinking about the Pentium chip or something like that.
Yeah. So I would say that when Intel first started making processors, it was a hey, they need this to calculate to this level, and there were probably specifications that outlined that were more performance oriented around the early days of the 8086 and for those of you that have been around as long as I have, a 286 and 386. There were probably more performance specs in that was more about, we need this to do all these kind of calculations. Then Windows came along, because Intel chips were along way before Windows was. And so that move from DOS to Windows kind of dictated that, now we've got some parameters we got to fit in then make sure it runs Windows, and which what was that? More graphical. So my point is, I think, as the example is, in the early days, Intel processor chips were probably very based on performance specs. Today, I think it's probably more on design specs, because I know my experience with Intel, because I have a lot of experience with it, is it's like, it is very, like, the step ups they're doing are very specific. And because years ago and decades ago, they set parameters for their chips, and now they're just chasing, was it nanometers? It's just all their wafers and their silicon are just getting smaller and smaller, but is the chip itself getting smaller or bigger? Well, a lot of them are the same size, some are bigger, and then that's when you get into, well, different models. You got Pentium versus Xeon versus whatever else. So that's what I think, again, thinking of product management and our role in product management is, you've got to look at things like that. And then again, my experience has been, the earlier you are with a kind of a newish product, the more you can really drive performance specs, which is preferable, I will admit, more than design specs, because a lot of us just feel like design specs makes it feel like you're constrained. But my point is, but there's always a need for some of that type of product. And it's key for us in product management to recognize, and be situational aware about when would my product might need to be dictated to be very purpose-built, customized, design spec design versus performance spec. The other thing about this as a product manager, and this applies more to the hardware world than software, but you also think about when it comes to procurement, what people have found is when you have a performance spec, then volume doesn't matter near as much. And when it comes to procurement type of aspects of product, when you have something that's has to be this way, like that dishwasher, then volume, it's not so much where the cost of it is driven down that much more by volume. Whereas if it's a performance spec product, you've got a lot of leeway. You've got ability to make on other add-ons to the product, for example. So just things to think about. That's really my main point here. It's not about which spec is better. It's recognizing which spec you might want to need based on your customer outcomes. Sherry, I have see you raise your hand. So what question do you have?
Yeah, she had two follow-ups to just what you were saying. And Sherry's mic isn't working, so that's why I'm conveying these for her. So the first is, well, how might it matter whether or not to call it design versus performance spec?
Well, yeah. So those aren't terms that are typically used, I guess. I mean, I've learned them, but forget about the names. Just recognize the differences. Again, that's my point is there are differences that you need to recognize upfront when a product is in its early stages. You're going through your business case, your case study. You get to a canvas of what you want the product to be. Then you get into more of your, product requirement document, marketing requirement document. You've got to start outlining. It's that outline. And so the words of design spec and performance spec aren't something that's that critically used. It's just note the differences there of each and where they might benefit you, and where it might benefit your customers. So I hope that helps.
Yeah, and she had a second one, just to go maybe a little deeper on your procurement thought. You were talking about procurement of product.
So one example is there's been, there's always acquisitions, mergers of companies. There was a case study done of some companies. One company bought the other, and as they were analyzing their procurement practices and their cost, one had higher market share than the other. So the thought was, well, the one with higher market share must have lower cost because they can base it on volume. But that higher market share organization used this basic design specs. They told, their factories and their designers, we have to make it this way. This is the only way you can. That locks them into a design that then is not susceptible at some point where volume keeps lowering the unit cost. Whereas the performance spec, this other company that had smaller market share, smaller volume, had what they used performance specs. They said, I just want my product, to be like this. That it needs to. Here are the outcomes the customers we want the customers to achieve with our product. And what that did is introduce a lot more flexibility and capability later on for hardware, which we know when you lock in a design, it's hard to change it unless you completely revamp the product. But in this case, they were able to make it flexible enough to where they could add accessories and options to where they took out the volume issue from a product cost perspective, which was an amazing outcome there, because everyone just, hey, volume is everything. You get volume discounts. If you've got higher market share, that means you have higher volume, you have higher leverage to your suppliers. But in reality, at some point, maybe, there's got to be some scale there, but at some point, performance specs provide more flexibility, and therefore the cost was about the same. It wasn't like this, X percentage difference. So that's really where, from the procurement standpoint on hardware or software, you get that. It just kind of plays out that you don't need a lot of volume to get the best cost because you've got more flexibility in your design. That's where I was trying to go with that. So let me go on just a couple more slides. It's just another example. And so behind the scenes of a television, an LCD television, is what they call the color gamut. And this is definitely software driven, but when you look at, this is basically the range of the red, blue, green color gamut that TVs and LCD, anything LCD has. Typically, there's just like a one standard red, green, blue data point, which would be any of those triangles, right? Of green, red, blue, and there's a lot of numbers behind that. But that locks in a design with one, and in reality, there's about a dozen different standards around the world for different colors for different use cases. So for example, if you're a professional photographer, you want a color gamut that's X, let's just say. I don't know all the data points. If you are if you work for DreamWorks, if you're an animation studio shop, you have some other standard, or not just one, maybe three different standards. Rec 601, Rec 709. I mean, there's several of those, is my point. My point is, in most cases, like LCDs and LCD-based products, notebooks, TVs, whatever, monitors, have just one. But there was a few products now over the last 10 years that have gotten, they programmed in several different color standards into the design of the LCD to where the user can adjust to what their best needs are. And again, it came out to be, that's a performance spec, because the PRD for that product was, I want 4 different users to be able to use 4 different color specs. And so designers made up with a software that had the list of all these different color standards, and then a couple extra buttons on the product, and then a user could change and tune in or tune out of one color spec to the other. So a great example of expanding what was a design spec kind of product to a feature set product, spec product. Again, just going through over the next couple of minutes, again, talking about going from high level to low level as your product management career progresses, and you go from strategizing your product down to like really getting to the net node. Okay, I'm scrumming this thing every day, so stand-up meetings every day, and you're starting to deliver and starting to go through that continuous delivery process. It's getting very detailed. And so you've got to, again, recognize where you're at with that process. And like I said, products are going to evolve as well. And so, maybe your specifications change because the needs of the customer changes. Again, if anything else, all I'm trying to get to is you all need, and we all need as product people, to recognize when that need changes. Get yourself in position to change your product before someone else does, as in competition. That's another thing. I won't go through all this, a lot of detail here, but again, it's just more of the framework for outcome-driven kind of product development. And as product managers to know that, there's a lot of things we can do. And I think a lot of the other sessions earlier today address some of these key things. Sorry. So kind of one of the last things is kind of just another example. And this is where I'd like to hear from you all in your products. So between the two different specification scenarios I talked about and software, hardware, services, these are some of the examples I had in terms of where a design-based spec could apply in software. Like I said, the API that can be very specific. And I know APIs can be more than that. Some very customized hardware, purpose-built hardware, or even in services where, if you're doing installations and deployments, those are very specific and they really have to be done by a very design-based kind of thing versus a customized thing where, hey, you've got carte blanche on how this thing can work. So anyway, I'd like to hear from you all about, what kind of products do you do and where do you say they fit in this kind of matrix? Anyone open, unmute, let me know.
All right, thanks, Andy. Yeah, so this is a good time for people to chime in with questions. I think this time we answered questions as we were going. So there's none in the chat, but please, now's a good time to bring any questions you had, or to, as Andy has requested, share some of your own insights.
Christian, you got any questions? You opened up your video, so I didn't know if you had some to ask.
I was going to ask you a question. So I do foresee all APIs in Adobe Commerce, which are both design and performance specifications there. Yet I'm concentrating a lot more on design these days because, many companies have focused their goals as to developer experience and all of that, but APIs by definition have to be performant, and it's like 100 milliseconds response time. It's such an example, and it's very generalized these days because often depends, but that's what I do.
Yeah, well, good. Yeah, again, like I said, I'm more around the lines of, regardless of what you use, is recognizing the types of kind of requirements I'm talking about here and how they would apply. Because I spent a lot of time in the world where we were building purpose-built products. It was, in a computer world, we still use the word appliance. All I needed was this one, small PC or my Raspberry Pi. I've got one over here. I needed to do one thing and one thing only, and do it all day long, every day of the week, every month, week of the month, every month of the year, etc. And that's to me, that's a very design-based kind of spec versus something that has uber flexibility, and I know that there's a gray area here when I think about cars and backup cameras. I'm like, did someone say that we need to have this specific camera on the back of a car, or just someone's requirement said, I need a driver to see behind their car without mirrors or instead of mirrors or whatever, in addition to mirrors. So that's what the kind of things, the questions we need to ask ourselves. Sherry, your hand's up. I don't know, or Michael can relay it to me.
Yeah, so what are examples of increasing flexibility or capability? Was there a question?
Yeah, okay, well, so
like, again, I'd say when it comes to hardware kind of products, it's more of a, how many options or accessories do you have that enables a user to get more out of the product? Again, software is sort of difficult because if you're in a iterative process, software can always be updated, and you can eventually kind of work your way out of one area to be more flexible or to add more features. I mean, that's where it is. I think most of the time it's adding new features or adding new capabilities to the same base product. So I know we're out of time. Be glad. I'm going to be around on Slack later on. Love to keep the conversation going out there, or link with me on LinkedIn if you haven't already. And